Okay, for number 9, the distance traveled by a man in any hour after the first equals a constant number of miles plus a number of miles which varies inversely as the number of hours traveled before that hour. If he travels 12 miles in the 6th hour and 8 in the 11th, how far does he travel in the 21st hour? All right, so I'm going to go to the whiteboard. I guess reading that is not the easiest thing to read, but I'm going to parse the language as we go to the whiteboard. So I'll have the question in front of me, but I do need to go to the whiteboard to do that. All right, let me delete this one here, and just I'll do a new whiteboard. Let me get a pen out. Okay, let's read it again. So I'm going to say the distance traveled by a man in any hour. So I'll write this over here. It's like I'm going to say X is the hour. So for example, X1 would be, the first hour, X2 would be the second hour, X3 would be the third hour, so forth and so on. All right, so I'm going to say distance traveled in any given hour is, and I got to read this, the distance traveled by a man in any hour after the first equals a constant number. So I'm going to say after the first. So X is going to be greater than 1. All right? So let me just read that. So the distance traveled by a man in any hour after the first equals a constant number of miles. I'm going to say that's K. I have no idea what it is. Plus a number of miles. I don't know what that is either. I'll say M. And it goes on to say which varies inversely as the number of hours traveled before that hour. Well, before that hour would be, let's see, that's going to be before that hour. So X is some hour. So it's going to be X minus 1 before that hour. So X minus 1. All right. And so you could write down certain things, like you could write down what D2 would be. D2, that's the number of miles walked in hour 2. Not walked, I'm sorry, I shouldn't say walked, but gone. Yeah, I don't think this is a walking problem. Right, because of 2, you get 2 minus 1 is, yeah, that seems okay. So let's take a look. It says, if he traveled 12 miles in the 6th hour, so X equals 6, and the D6, again, just reading it, 12 miles. I want to write that down for you, by the way. So 12 would equal K plus M over 5. I'm going to write that a little differently. I'm going to write it as 80. I'm sorry, not 80, 60. I'm multiplying both sides by 5. So 5 times 12 is 60 equals 5K plus M. All right, let's put the next one down, they say. And they say, and 8 in the 11th. All right, so X 11 and D, I'm sorry, 11, D 11, I'm sorry, not D 11, the 11th hour, yep, D 11. How far did he walk? 8. Put this over here. Let me write this down for you. So that's going to be, again, we're looking at the formula. This is going to be 8 equals K plus M, and it's going to be 11 minus 1, which is 10. Let me write that down for you. What do you get there? Multiply both sides by 10. You get 80, 10K plus M. Well, I think I can figure out M and K, although maybe I don't really want to know that, but I can figure this out pretty rapidly. And the way I do that, 2 equations, 2 unknowns, just subtract them. So 80 minus 60 is 20. 10 minus 5 is 5, and M minus M is 0. So what do I get over here? K is equal to 4. I certainly would like to know what M is now too, and I'll pick one of these equations. I'll pick this one here to find out what M is. So you get 60. Well, 5 times 4 is 20 plus M, so M would be 40. So I know my formula now. K is going to be 4 plus M is 40, over X minus 1, all right? Again, someone says, I wonder what their question is. Their question is, how do they travel in the 21st hour? So it's gonna be D 21. There's gonna be 4 plus 40. 21 minus 1 is 20. This isn't so bad, right? So 4 plus 2, which is 6. And the units in this thing is in miles. Let me just make sure they did say that. Yeah, they did say miles. So the answer here is gonna be, he travels 6 miles in the 21st hour. Thank you.